I'd like to talk to you about something called design patterns, and more specifically the model view controller design pattern. Now, the definition of a design pattern, according to the Wikipedia, is a general reusable solution to a commonly occurring problem. And the idea is that over the years, software engineers have developed effective solutions for particular problems, and that to save ourselves a lot of time, rather than trying to work things out from scratch, we can make use of these solutions when we design our software. Now, because the iOS platform is quite a modern platform, it actually builds a lot of these design patterns into its core. So you have to really understand design patterns to be able to develop effective iOS applications. The ones we're going to be using are three. We're going to start with what's called the model view controller design pattern, and we're going to be talking about this one in this particular video. But we're going to also look at something called a singleton pattern in the second session, and the fifth session we're going to look at something called an object pool. So let's move on to the model view controller. Now, model view controller development is really common nowadays in software development. Unless you're working with really antiquated tools, the chances are you're going to have to use it in your process. And the idea is it separates your design into three parts. The model controls the application state, the actual data to do with the application, the state, the way things fit together. So for example, if we were doing a bookshop app, the model would store the book details, how we interact with the book details, the locations, bookshops and so on, all stored in the model. The view, however, is purely there to display information to the user and to respond to inputs from the user. The controller is the bit that glues it together. The controller handles that user input and interacts with the model to retrieve and pass data. If we look at the simple model view controller, let's look at the communication between the different components. Now, the first thing we need to understand, does the controller talk to the view? Well, of course it does, because the controller has to send information to the view to be displayed, and it's important that the controller can access the view. The model is also accessible by the controller, so the controller can talk to the model and pass it data and request data from the model. Okay, that's pretty straightforward and it makes a lot of sense. Should the view be able to talk to the controller? Well, ideally, the view should be totally separate from the controller. It shouldn't know anything about the controller. Because let's imagine, for instance, we want two different views working with the same controller. For example, we might have an iPhone view and an iPad view. Well, let's imagine that we want to use our view with a different controller, which is quite possible. If we had a strong link between the view and the controller, that just wouldn't be possible. So what we do, we use several mechanisms to establish communication between the controller and the view. The key here is all communication between the view and the controller must be blind. So the view must know nothing about what class the controller is or anything about it. So how do we do this if the view knows nothing about the controller? Well, the first mechanism is called target action. And the way this sort of works is the controller hangs a big target on itself, okay, and it sends out an action to the view. So the view receives this action, and when the action gets triggered, it sends the message back to the controller. So as you can see, this means the view doesn't need to know anything about the controller. It receives everything it needs to know from the controller, and it simply uses that action it's been given. It's a very simple mechanism, but it's very effective, and we'll be doing this in our first demonstration. Sometimes, though, it's a bit more complicated. Sometimes you need to know, should something happen, or will something happen, or did something happen? Okay, so should something happen is, I've done something, should that trigger an event on the controller? Will something happen, is something about to happen, or has something already happened? And to do that, we use something called a delegate. Now, if you're comfortable with C++ programming, you're familiar with protocols. And the way this works is the controller implements a certain protocol, and by implementing the protocol, the view knows it will respond to these calls and these methods. So by implementing the correct protocol, it can respond to the methods, but the view still doesn't need to know what class the controller is. And we use that a lot when we start dealing with our controls and our Cocoa touch controls, which we'll do in the third session. So you'll see a lot more of this delegate and protocol in session 3. The final mechanism is all about data. Now, when you start developing, you think, well, if I've got this data, let's throw all the data into the view, and then that's it, job done. The trouble is, that's very inefficient. If you think about a table view, a list in iOS, you can display, 7 items on the screen at any one time? If you've got 50,000 records, it's not very efficient to send 50,000 records to the view if you can only see 7 at a time. So we have what's called a data source. What that does, it asks questions about the data set. So for instance, it might say, how many records are there in the data set? And the controller would go off, find the answer, and send the information back to the view, so it knows how many cells it's going to need. It might say, right, I can display the first 7 cells, so send me the data just for the first 7 cells. And the message goes to the controller through a data source, and the controller sends back the data. As you scroll through the list, it will constantly be sending requests for different data sets. Send me records 21 to 32. And that's how you get this beautifully smooth scrolling when you develop iOS applications, and why the interface is so smooth. Because it only requests the information it actually needs to get the job done. What about the controller and the model? We've already know that the controller can talk to the model. But what happens if something changes in the model? We need to tell the controller that the data set's changed so it knows that it can retrieve the new data. Well, the way it works is through a sort of radio station system. The model broadcasts on certain frequencies, and the controller is tuned into those frequencies and responds to the message passing. So obviously it's not really a radio, it's just the metaphor we're using, but it basically means when the data changes in the model, it simply broadcasts a message, and the controller can be set up to retrieve that message. But the model doesn't need to know about the controller. Just like if you're tuned into Radio 1 station doesn't need to know that you're tuned into it. It simply broadcasts the messages on a particular frequency, and the message may or may not be read by the receiver. So the model can be constantly sending out these messages, and if the controller's listening for them, it can be notified when the data's changed, then it has to go and ask for the new data. So that's the basics of communication between the model, the view, and the controller. But that's just a very simple example. And very soon we're going to have more complex examples where we need to have a more complicated system. So what happens in that situation? What basically happens is we can have multiple model view controllers in our application. So if you look at the example here, you can see that the controller, the bottom left controller, actually has 3 complete model view controllers as its view. So it can launch a complete model view controller to create another view on the screen. You can also see that controllers can share the same model. And you can see on the right-hand side that some systems don't have a model at all. And in fact, that's how we're going to start our development. We're not going to build a model until a bit later on. So as you build more complicated systems, you'll find that you have more and more model view controllers within your application. Now, what's really important is, no matter how complicated your design becomes, we always make sure the communication follows the same pattern. So the controller can see the model, the controller can see the view, but the views don't know about the controller and the model doesn't know about the controller. Otherwise, you'll just end up with chaos. And debugging, fixing problems in your code is going to be almost impossible. So hopefully that's given you a short introduction to model view controllers. There's lots of the resources on the web which you can use to learn more about them. In fact, there's whole books dedicated to design patterns, which you might want to look at if you really want to get into this. But hopefully it's given you a little overview of the process, and you now understand a little bit more of how the model view controller works.